Relation. What is a relation? We're going to start this with a problem and then we're going to define it much better. So let me start by giving the problem. Given that x maps to 2x plus 6 and scribbly bracket, you can see it here. We'll be reading this much better right now. Just let me write to the problem. Less than or equal to x less than or equal to 2. Now I want to leave this very small distance so we can work with that. Okay, then a table of values for the relation. Okay, so we're going to look at the relation y equals 2x plus 6. The way we're going to read this is as follows. Given that x maps to 2x plus 6 and x is such that negative 2 is less than equal to x, which is less than or equal to 2, then a table of values for the relation y equals 2x plus 6 will be working with that. So therefore I'm going to make my table. And when I make this table here, let me put the values that we will be working with. You are not, once you have set your table range, you are not to exceed those values. So I'm going to put here x 2x plus 6 as how it states, and then the value of y. The range goes from negative 2, negative 1, 0, 1, 2. Okay, so this is our table, a very basic table which we are going to be working with. And for problems of this form, it's recommended that you do a table. If you can't picture it a certain way, maybe this can also help, right? So, and it's very basic concept, so I'm going to leave the table in that form. Now take note that this says that every 2x will be added 6. So here's a plus 6, so we can easily put plus 6 here, plus 6 here, plus 6 here, plus 6 here, and plus 6 here. That is to populate the table. Now this means that the x values will be replaced by the values at the top here. So we'd say negative 2 times 2, because it's the value of x. We say negative 2 times 2, that gives us negative 4. Negative 1 times 2, negative 2. 0 times 2, 0. 1 times 2, 2. 2 times 2, 4. Now we're going to add down, because that's what they said, add it to get the value of y. So negative 4 plus 6, that will give us positive 2. We'll leave it as that. Negative 2 plus 6, that gives us 4. 0 plus 6, that's 6. 2 plus 6, that's 8. 4 plus 6, that's 10. Okay, so those are the values. Now the notion, so let me write this here. The notion, the notation x arrow 2x plus 6 means, and let me write this so as to people can see it, means x is mapped onto 2x plus 6. For every equation it will change depending on what you are working with. Okay, therefore what we can do now is that we can write a set of ordered pairs. What is the set of ordered pairs? Okay, so we're going to be defining that also. So this is what is known as a relation. Okay, so let me give the definition of a relation so you can review that back also. Here is a little bit more. A relation is simply, and take note of, based on the example that we use, is simply a set or collection, because it's a collection, you can say also it's a collection of ordered pairs, Now what do we mean by ordered pairs? It simply means that you get the result based on a particular condition, or in this case mathematical equation. An ordered pair, okay, commonly known as a point, because we know it has two values, has two components, and at this point we know what are those two components, but to make sure I need to review it. Which are the x and y coordinates. Each point has both x and y coordinates, okay, or values. In other words, a relation, and take note of this piece here, a relation is a set of ordered pairs that obey a particular rule. And what is this particular rule? The mathematical equation which we just did. Okay, this means now, as an example, I'm going to use the numbers from up here. So as an example, -1 and 4 is a set of ordered pairs. In this point, okay, -1 is the x coordinate and 4 is the y coordinate. Okay, so we have identified what makes a point. What does the point have? It has both components, x and y coordinates. So therefore we can take the set of ordered pairs from right here. So the set of ordered pairs for this particular problem is as follows. You're going to make a squiggly bracket at the front and start to make brackets for them. -2 and 2. I always put the x value first and a bracket in between each point. -1 and 4, come out so it separates. 0 and 6, and then 1 and 8, and then 2 and 10, close bracket, and then bigger close bracket to represent that those are all of the elements as points in the set of ordered pairs. The set of the first values, so if we were to take out the set of the first values and the set of the y values, or the second values, we have what we call the domain elements or the range elements. So let us see what does that mean. The set of the first values in each point in the set of ordered pairs is known as the domain elements, which are, take the first element in each point, do not repeat the element. Okay, and if you notice, these elements are the same elements based on this range here. Okay, and these are the x values and these are the x values. Okay, so that is what we have with that one there. Now let's go with the other elements now, which will be the y values. So we take this problem here and we move it to the side, we work with it, I'm going to keep this here so we can follow that we're still working with the same numbers also. So the second set now, the set, or in other words the set of the second values in the set or, as how we may call it, ordered pairs, is known as the range elements, or they are the elements of the range. What does that mean? Our big bracket, and we start to look at the second elements. Okay, we are not to repeat any elements. So we have 2, we have 4, we have 6, we have 8, and we have 10. Take note that I took the second elements in each point. Okay, and these are the y values. Okay, or in other words, the y coordinates. Not. So now we have described that this is a relation. We have seen how we can give it as this notation, and this set of elements summarized here. Then we can make it in form of a table, and we can also see that by definition it follows a particular rule or a particular pattern. We have been able to identify the x values and the y values. We have been able to call the x values as the domain elements, the y values as the range elements. Okay, now can this be set on a graph? Yes, so we'll be setting this on a graph. So let me start by bringing out a graph paper, and I'm going to be putting the numbers here. We know that they go from -2 to -2 to +2, so I'm going to make it a little bit much more bigger, because we know it needs to go to 10. So we have 1 2 3 4 5 6 7 8 9. That would only have reached to 9. And so let me bring this down a little bit more. I'm going to have it right here, and I draw my x-axis. I'll make it as dark as I can so you can see it. So now we have here 0 1. Let me make it this 2 spaces. Okay, you can see it. 1 2, -1, -2, and I'm going to draw our vertical line now here, so we can represent this on a graph. Okay, 1 2 3 4 5 6 7. It will not fit, so I'm going to keep my y values as 1 centimeter for every element distance. Okay, since we already know how far it will reach, I might as well do all of the elements one time. That's 1 2 3 4 5 6 7 8 9 10, and it goes infinitely. Okay, so now I'm going to be labeling my points now. So I recall back the information as what are the points. So I bring my points here, I bring my graph, and I start to plotting my points. So according to this, it tells me that the first point is -2 and 2. So I go to -2 on the x and +2 on the y, which is right here. Okay, and then I go -1 and 4, which is right here, and then I go 0 and 6, which is right here, and then 1 and 8, which is right here, 2 and 10, which is right here. Okay, so now can I draw a line to join them? Well, we can draw the line and join them, because that's the thing with this, that we can join them and even find even more points of what the relation would be based on if we were to extend it even more our range. Okay, so we have this as the line. This is the line that goes infinitely up and infinitely down, but you only start from here to here. Okay, just remember that. So this line has the equation now as to say y equals 2x plus 6. We have that equation. This is the range. This side here is the domain, and so we have all our information there. Okay, so that's how you can represent it on a graph, by plotting the points and drawing a line. So that's to represent it on a graph. Now this relationship can also be shown on an arrow diagram. What is an arrow diagram? Okay, so this is a graph. Now we're going to the arrow diagram of that same information. So arrow diagram, let me write it here. Arrow diagram. The arrow diagram will have two things. We'll have the domain and we'll have the range. We had how many points? 2, 4, 5 points. So here will be one of the points. 1, 2, 3, 4, 5. And so we can draw a circle this way, which is the most standard way people tend to use it, and you might find it this way, but not necessarily may come as a square or rectangle. It doesn't make a difference. Okay, and so I want to put points here to represent where elements might be. So I put my domain. Remember, we listed our domain. Our domain in this case were -2, -1, 0, 1, and 2. So after we did our points, we were able to plot them, and we got values as 2, 4, 6, 8, and 10. So those were the elements in the range. These are the elements in the domain. And then because we are drawing an arrow diagram, then we simply join from this point to this point. In that direction, point the arrow, this one to this one. In other words, each one of these elements have a result. Each one of these elements that you inputted gave a result. So this is what we call it follows a particular pattern. You have a particular rule. So this is an arrow diagram showing the relation or mapping diagram. So it's arrow diagram, and some people may call it mapping diagram. So let us go over what we mapping diagram. Let us go over what we have covered today. We went and we identified what is a relation. We made a table on the equation, and based on what we are to put our values. Then we went over and we defined what's the relation all about. We have a domain and we have a range. The domain elements are the x values. The range values are the y values. Okay. And then we said that they can be set in a set like this as points. We said that each point can be plotted on a graph, and then we can also plot it on a mapping diagram or arrow diagram. Now, based on all this, we're supposed to be able to state if it's a relation. Now, take note, it follows a particular pattern. Or a relation is simply a set of collection of ordered pairs. Once it's collected a set of ordered pairs, then that's a relation.